What is the value? So let's try. We can print that. For example, if we do quick then we install. Oh, we still have that. Okay, let's try print dollar all SP. All SP is in that memory, particular memory. RSP, I got RSP from right here. This is RSP. This is a label on that memory space, specifically that is in this memory. In hex, 7F, FF, 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 DF50, then 1, 2, 3, 4, 5, 6. 6 byte memory. Any of that. RBP, RSP is RSP. And RBP, if you want to see RBP, and you print also. Print RBP. So another space.
Professor, what is doing with the
division,
RBP?
for example, hold on, division. Here, divided, right? Division. So we have to divide. So we will take a look at those two variables. So print and dollar EAX is 3, and then print dollar $XMM0. That is the problem, right? What I'm trying to see here, there's a division here. I try to look at EAX. EAX is 3, right? Actually, 3 divided by 0. That's what we did above. XMM, this memory has all zeros, double 0, 0, 0. But anyways, somehow it displays that. Question?
You know, I was looking at this part. So when you recognize the RBP, is doing that. So it's pushing for the first line. So we are entering the main. The first thing that is doing.
This is the address of that statement,
okay.
And this address of this particular is given by.
Yeah, it's recognizing with 1, or is not? It's just giving us the address.
That $1, the first variable is stored at that memory address.
Okay, here.
There. And the second one.
So it's going to be the A. The first integer that we are, the first variable it was A.
Possibly, that's what we guessed,
A,
right?
B, and C.
Yeah.
C was the one that we were looking at.
Somehow. But right now, we don't see yet the core dumped. Core dumped gives you more information of that error. So quit this and let's go back. And we need to do core dump. If you want to do core dump, by default in Ubuntu, dump is not allowed. If you have very long code, very complicated code, and if it automatically core dumped, then memory consumes so quickly. So by default, core is not dumped. Now you need to allow core dump. The command that you need to enable the core dump is ulimit and -c. There's a for code, core code, and size of the core code. you can specify, for example, 1000 bytes or whatever. If you say unlimited, that's fine too. So U limit -c followed by the size, but you can say unlimited. Then now you can do core dump. The command that we did here, gcc -g, no, not, there's a compiler. To run, right? How can you run? We do addr, then core dump, and then ls. Now you have a core, right? The size of a core, look at the size of the core. A lot bigger than anyone else, right? This is the size. This is the size. This is the size of that core. But all others, a lot smaller than this. So by default, in Ubuntu, core dump is disabled. Now we enabled and then generate the core. Then our GDB debugger will do not only addr but core together. So it points you directly. What it does is that, oh hey, there is a problem. Right? It's very, very handy. It gives you, oh, this is the problem. If we want to see this sample right there, then you can see here. It gives you exactly, here is the problem. Where's my mouse? Okay. It points out this assembly code generates the error. That's what we looked at, right? So you can print $RDP that, and how can I see? Let me find out. I need to see. I forgot the command. How can I see? Let's try it. Here, print see what is there. This. Print. Copy. Print 0x7 that number stored that place. That's the means. Let's take a look the slide. So with that much experience, let's take a look. Okay, so we do that. And we do disassemble so that we can look at assembly code. And this is the assembly code as you looked at, right? All of those. Similar to that. Not exactly the same because each machine has different allocation. Step frame. If you have a program, source program, then there is one source file, and it has a stack frame. Each block is nothing but frame. So we call that stack frame. In the source code, it has parameters. Remember that function, then function takes input parameters. Parameters sits somewhere in the memory, and then return address, because it should know if you say void function, if it is void, then there is no return. But if you say int function, then of course there's a return address there. And followed by then you have a block of source code of that function, specific function. Then code block here, there's one frame. And that code block can execute another code block, then one frame code, another frame. Within that code block, you have local variables. So all together, for each function, for example, then that is one stack frame. So you have multiple stack frames available when the program executed. And then each program, each function can store in certain order in the memory. Therefore, we have a lot of pointers available. And if you go to that pointer, then you can see some specific values, as we'll look at a little bit, right? In GDB debugger, see we can follow some of the pointers, and also we can print out the content. So tutorials there. Okay. So what we will do, we're going to take a break. Meanwhile, if you are interested, refer to those tutorials and some of the links. Okay. This is posted. Blackboard. So let's take a break, about 20 minutes.
Does anybody install VirtualBox on your hard disk?
Mine is on. Hard drive?
side, on your